All right, good morning, everybody. Today we are going to be reviewing what we've covered so far in Unit 10 and 11. And in order to complete today's assignment, you do need your notes packet because you are going to have to look for some of the questions that match the notes that we did so that you can use them to help guide you. The other good thing to have out is, of course, your word wall. So remember, this is a great time to kind of make annotations, add things to it that you might need, but you're going to need those two resources to complete today's assignment. Now, to get us going, the first page of this packet is a we do, meaning we're going to do some similar problems that you're going to see in the rest of the packet, but please understand that not everything that we cover in this first page is in the assignment that you have behind it. That's why you need your word wall, and that's why you will need your packet to be able to complete it. So we picked and choose a couple problems that we wanted you to practice with us. So this is in preparation for the next test that you will be taking for this class. And so we said, you know what? Perfect day to start reviewing little by little. We're kind of at the halfway point. Okay, so question number 1 says solve. The thing that needs to stand out to us is the fact that there is a radical or a square root symbol. But when I look, the x and the 5 are both stuck inside of it. And we've said the only way to get rid of a square root is to bring in a power of 2. But I can't bring it in yet. See, when I'm looking at my equal sign here, we notice that the 4 is kind of in the way. So we do need to get rid of the 4. And remember, as we are solving here, right, it says square root equations with one radical, isolate the radical. And that's what I'm trying to do right now. I'm trying to get this radical all by itself. So I'm going to subtract a 4 from both sides, leaving me with the square root of x minus 5 is equal to, and 7 minus 4 is just a 3, but this is what we needed to look at. The fact that when I look at this and I say, all right, well, is there anything else in front of it? No. Remember, I'm covering the equals. Is there anything else behind it? No. And again, you cannot get rid of this 5. It's stuck in there. Well, let's get it unstuck. And the only way to get it out of there is, of course, bringing in a power of 2. Just remember that when you do give it a power of 2, it means 3 times 3, not 3 times 2 there. And so 3 times 3 is 9. So we're going to bring that into our problem. So now it says x minus 5 is equal to 9, which leaves us with one step, right? We can finally mess with that number 5. And so, of course, we will add the 5 to the other side. And we get our result that x is equal to 14. And just like that, we have our first answer. But again, the word wall said, isolate. Get whoever's inside of the radical, right? Get this entire orange radical all by itself. That was priority number 1. In fact, let's zoom in nice and big here a little bit more. Now, when I look at number 2, I have this radical, and the x is stuck in there, but everybody's stuck in there. I've got this radical where everybody is also stuck inside. Well, let me look at my word wall. It says solving equations with 2 radicals. So the difference between these two right here is when you have one radical, it means there's a radical and it equals some number out here. This one is saying, what if you have 2 radicals? Most likely like this. Well, one radical on each side of the equal sign. That's what we see here. And look at what it says. Square, meaning give it a power of 2. And it says to do it to both sides. So again, the word wall's here to guide us, but these are the little details that will help us understand, like, hey, maybe we should write a couple things in here. 1 radical versus 2 radicals. So it says square both sides. So this one is ready. There's nothing for me to move. So I want to release the radicand, the inside of the radical. I want to release that. So we were trying to get it out. Well, the power of 2 will do that easily, leaving me with 5x minus 2 is equal to 3x plus 10. All right, well, now it's just a basic solving, right? We're trying to get x by itself, but we never want 2 x's involved. But I do need to move it over to the other side. So as always, only adding and subtracting will move an entire term. So minus 3x minus 3x on both sides. We end up with 2x minus 2 is equal to 10. Now, standard solving, we'll get rid of the adding and subtracting next. So we'll add the 2. 2x is equal to 12. And when we divide by 2, we get our final answer here, where x is equal to 6 with just enough space in there. All right, well, again, that's us using the word wall. Now, this is Unit 10. This is what we've been working on recently. The one thing you have to note is that when you're taking the test, there's all these throwback questions, and that's what I want to make sure we continue to review with you. In the previous test, this was the question that a lot of people got wrong, not just in our class, but just in general with all the algebra classes. We are graphing. Your backup is you could always make a table if you wanted to. But when we graph, we want y by itself. Well, if we can spell it there. By itself is what we want. And so the y is not by itself. Well then, let's make a couple moves. And again, these are all things you've done in the past. If you want to get the y by itself for graphing purposes, well then move everything else around it, and no, you can never move the number right next to it first. We always get rid of adding and subtracting, so I need to get rid of the 6x. So I have 2y is equal to negative 6x and a positive 4. See, I'm trying to get it in order. Y equals mx plus b. The variable should be first. Now, of course, I can divide everybody by 2. And remember, we give everybody their own little 2 here. And just like that, the y is by itself. Negative 6 divided by 2 is negative 3x. 4 divided by 2 is just 2. This is what we want for graphing. Again, I could always just make a table and use a calculator to figure out what points to plot for this problem. Or we use our knowledge of lines, and we know that this right here is our y-intercept. So if the y-intercept is 2, well then go put a dot up there, right at the 2. Remember, it's called the y-intercept. You need to be on the y. Still an issue for some. Right here, the negative 3 is our slope. And if our slope is negative 3, but I'm graphing, we put a 1 under it. And then, of course, this is how we count. We're going to count down because it's negative, but always to the right. So I'm going to count down 3. 1, 2, 3. 1 over. So there's another dot. But we have room for another. 1, 2, 3 spaces, 1 over. And so we take our card, right? Something to make our straight lines. And we draw our line. But again, this one continues to be a little bit of an issue for some. Graphing, you have two options. Get y by itself first, which is the good option here, so we can use this technique, or you can always make a table. So again, these are the throwback questions that we're concerned about, especially with the final coming up. So we want to make sure we review those the most. All right, so look at this one now. 3x plus 6 is equal to negative 15. All right, well, there's no power of 2. There's no radical. It says solve. Your goal is get the letter x by itself. And if there's no power of 2, there's no radical, then this is super old school solving. Just start moving things. Subtract your 6 to both sides. Remember, be careful with your calculation here. We would end up with 3x is equal to negative 21. We're combining two negatives, keep that in mind. Divide by 3. And so we get an answer that x is equal to negative 7. In the last test, we gave a question very similar to this, and that was the number one question we got from people. They go, so wait, do I just solve this like I always do? Yes, you shouldn't be asking that question. It's always in that form. It's just solve. Get the letter by itself. That's the goal. And then, of course, people didn't do too bad on this one. Remember, at this point, slope, you need to already understand that if you're going to find the slope, well, you need to use the formula, especially if they give you 2 points, where you subtract some numbers. And yeah, you have to backtrack for this one when you're trying to figure out, okay, well, where's my slope formula? Well, the first thing you start doing is start looking for pictures of lines. And look, I found some lines right here. There's the formula for slope, given 2 points. And so the y's are on top, the x's are at the bottom. So I like to organize my points. And by that I mean this. Look, let me go with 2, 3, because they're positive. Let me go with -4, -3. And then just remember, these are my x's, these are my y's. So the WordWall says, well, you have to put your y's on top. So 3, and yes, you have to write the extra -3. Then, of course, it says, put your x's next. Well, if I went in this order with the y's, I'd have to do the same with x. So there's a 2, there's a -4. And then keep in mind, that's the great thing about our calculator here, is the fact that we can actually just type it in exactly the way we see it. It's a lot like that decimals one that we practiced a while back too. So there's my fraction button, and exactly the way you see it. 3 minus, when it's in parentheses though, you use the negative button. 2 minus sign, in a parentheses, that's a negative button. And once we hit enter, well, look at that. It actually turned out to be, I don't even need this fraction line. I thought it might be a fraction. Who knew? That it was just going to be the number 1. Which makes sense, everybody, because when you do your double negative, it becomes positive, so that's a 6. Double negative becomes positive, that's a 6. So 6 divided by 6 is 1. But I just wanted to show you that if you have the resource, the tool, use it. So again, we're trying to show you some of these old ideas that keep coming up on our test, but we need to keep reviewing as much as possible for it. Speaking of review, well, here's some old stuff again. This one says, write an equation of a line. Notice they gave me the slope, and they said it goes through this point. Well, there's my m, there's an x, there's a y. They're giving me 3 pieces of information. So luckily, I think we just had it on the lines. Yes, when we were talking about slope, it's from the same unit 4. But here's where we look. Writing an equation of a line. Write an equation of a line. We always give you clues in the problem on where to look in your word wall. So we do have 2 options. They said, well, you can use you can use this formula, or I can use this formula. Think about it. You have 3 pieces of information. So even if you just think of it that way, this one makes no sense because this one only needs 2 pieces. And besides, it says you can only use this one if there's a 0 and then a number. That's not a 0 right here. That's a -1. Then we go to our classic point slope formula, where all I have to do is fill in these 3 spots. So that's the one we're going to go with. Y minus y1 is equal to slope times x minus x1. And when we're talking about filling in, yeah, I'm filling in this spot, and this one as well. And so, look, it already has a y and a minus. That has to be there. It has to have the x and the minus. Again, it has to be there. It's these 3 spots that I'm filling out. So we do it very carefully. It says I need a y value. Okay, well, here it is. That's the 3. I need an m for slope. Well, they gave that to me over here. They said there's your m. It's 5. And then, of course, your x. Well, the only number left is -1. So, yes, you need to give it that extra negative. And we'll fix that, of course. So this is point slope formula. Now, we can clean it up a little bit. We could say y minus 3 is equal to 5. And then remember, the double negative just becomes a plus. So this is one way of writing the equation of a line, but they might want you to take it a little bit further. And if they want you to take it further, you'll be able to tell with the multiple choice questions. If they don't look like this in your answer choices, well, then you do have to take it further, which is parentheses has always meant multiplication to us. So we do have to understand the foundational math skills that we have, which is as soon as we see a parentheses, we start thinking about multiplying. We don't question it. We just do it. It should come naturally to us. So 5 times x is 5x. Don't forget, 5 times 1, though, is 5. Don't put a 1 there. You need it to multiply. So the only thing left for me to do is to get rid of this 3. So we add the 3 to both sides. Obviously not here because it has an x, but I can definitely add it to this one. And just like that, the y is officially by itself, leaving me with 5 plus 3 is 8. Now again, as I mentioned before, these problems that we're doing on this first page aren't going to cover everything you see on the next few pages, but they will help you with some of them. We just kind of chose some problems that we knew you guys were still struggling with for some of you. Some of you already understand this. Now, 2 more to go. Now look at number 7 here. Number 7 continues once again to be a problem. We are solving a system. Notice, when it says solve, that means you need to tell me what x is, because I see an x. But you also have to tell me what y is, because there's a y. And that's why when we do this, we always write our answer as a point. There's the x, there's the y. But that's what people are still not understanding. When they say solve, you need to say x equals. But there's also a y, so you also need to say y equals. So when we're solving a system, we do have a couple techniques. And again, I'm just going to go around my word wall here, just flipping through it so that we can find it. But you see, I already saw the word system. And I saw something that looks very similar. Look, 2 lines. Now, this one says graphing. Well, I don't have graph paper, so that's not going to help me, right? It only works if I actually have graph paper for it. All right, well, now let me look at the other one. Solve a system by substitution. It says the variables by itself. Look at the example. It says y equals something. Well, none of these say y equals. They also don't say x equals. So this is probably not a good option for me, which means I'm probably going to use elimination. See, this one looks like it. There's x's lined up. There's y's are lined up. The numbers are lined up. Cancel out inverse terms and simplify. But when they say cancel out, this is the one thing we need to put by adding. So what we noticed in the last test was a lot of you said, oh, these cancel. They don't cancel. You haven't done any math. You haven't said you're going to do any math. The only way that the negative 2x and a positive 2x, and if you did recognize that there is some canceling that can happen, that's great, but you have to show it mathematically, which means don't just cross them out. You got to let people know that you're about to combine. You are going to be adding straight down. And so when you add them, now you can say negative 2 plus 2, gone. That's why they cancel, because of this plus sign right here. That's what's causing it. But if you don't show it, that's why some people canceled it out during the test and then said, well, I don't know what to do now. Well, it's because you never told yourself what math you were going to do. Now that I know I'm adding, well, what's negative 1 plus 3? Well, that's 2y equals 9 plus 1 is 10. And then that was the other issue. A lot of people did this and then said, but now what? You are solving. You have to keep going. The whole point is get the letters by themselves. So when I divide this by 2, we get y is equal to 5. There we go. We officially have one of our answers. There's 2 letters. So it's not enough yet. We still need to find one more. And remember, to find the other number that we need, right, for x, all you have to do is plug in. It's what we do nonstop in this class. Now, if you're wondering, which one do I plug it into? Well, you pick. You can pick any one you want. I like to make my life easier and not pick something that has a bunch of negatives. So I'm going to work with this one right here. I'm going 2x plus 3y is equal to 1. And then look, where am I going to put this 5 that we just found? Well, here's the y. Well, then that's where it goes, in a parentheses. That's where it should be placed. I don't know what x is, so you can't plug in for it. So it says 2x plus 3 blank is equal to 1, and there goes the 5. So I might run out of room. I'll just move it over. 3 times 5 is 15, is equal to 1. All right, I'm going to bring the work over here, but look, I would subtract the 15 to both sides, and because I'm out of room, here's the 2x that's left, here's the equals because the 15 is gone, and 1 minus 15 is negative 14. All I do now is just divide by 2, and just like that, we have officially solved. Solving has always meant, say, x equals, y equals. So in this case, x equals negative 7. Well, then I bring it here, which now allows me to bring it here, and this is our official answer for this problem. Again, it says solve. Solve has always meant, tell me x equals this, or y equals this. Well, in this case, I need to do it twice. Which brings us to the last problem. Now, the last problem is related to the newer stuff we've done, right? Mean, median, mode, everything else. So we're going to do a couple things on this one. I'm going to have to move it up, everybody. Now, Beth works as a salesperson at an electronics retailer. The table shows the number of computers that she sold each month over the past several months. What is the mean, the median, the mode of the number of computers sold each month during the period of time? Round your answer to the nearest tenth. All right, so if you notice, we have a list of numbers. Well, we already said, if you want to make your life a little bit easier, first of all, they wanted three things. They want to know the mean. So I'm going to get an answer column ready here. They want the median. Just going to get it ready. And they want the mode. They asked for three things. Well, write them down so you don't accidentally think, oh, I'm done with the problem. Not if you haven't answered all three. Now, when they give me a list of numbers, what we've said in the past is put them in order. See, the smallest number I see is 4, but I see the 4 once, twice, 3 times. So let me write it 3 times, 4, 4, 4. See, the next number would be 9, and there's 2 of them, so 9, 9. And then a 10 and an 11. So a 10 and an 11. Okay, there's my list of numbers in order. We don't really need all those words up there anymore. All right, well, let me answer the easy question first. The mode. Remember, if you're looking at your word wall, and again, this is why you need to annotate as much as possible. But when I'm looking at my word wall, the mode just means the most. What's the number that appears the most? So when I'm looking at this list, the number that appears the most, 4. See? That's the easy one to do. Fastest, easiest points to get. The other one that's kind of quick is the median. According to the word wall, it says, if you're going to find the median, aka the middle, put the numbers in order. Okay, we did that. The median is the middle number. But we did add this. If there's 2 numbers in the middle, then you're going to have to add them and divide by 2. Do I have to do this every single time? No. It depends on where you're going to make a cut. So, low to high, low to high, low to high, there it is. That's where I would make my cut. And if I'm making a cut, there's my median. If I'm making the cut and it actually goes through a number, then I don't need to do that division stuff. All I do is just write the number down and I'm done. That's the median for this data. All right, now, I saved this one for the end because I did catch a couple mistakes the other day. The mean. The mean is the average. And it says, add all the numbers in the data and then divide by the quantity of numbers in the data set. The problem is some people are going, so do I always divide by 4? No, this is just an example. They put a 4 here because they did 1, 2, 3, 4 numbers were added. In this case, letters. So they divided it by 4. But this should be the total amount of numbers there are. So they said, add all these numbers. All right, so here's the mean. 4 plus 4 plus 4 plus 9 plus 9 plus 10 plus 11. This is where I need you to be very careful. I'm not going to put a 4 down here. I have way more than 4 numbers. There's 1, 2, 3, 4, 5, 6, 7 numbers up there. Then you should be dividing by 7. So we're going to let the calculator obviously do all the work for this one here. So let's see if we can squeeze it in here a little bit better. All right, so here we go. I press the fraction button first. 4 plus 4 plus 4 plus 9 plus 9 plus 10 plus 11. And then at the bottom, of course, the number 7. And so I get 51 over 7. Remember, press the double arrow? And that's our mean right there. 7 point, I know it says 28. They said to the nearest tenth. So they're saying you need to cut it off at either 7.2 or what's next after a 2? Well, 3. So it's either 7.2 or 7.3. Well, let's look next door. There's an 8. So that means I'm closer to the 3. So we round it up. All right, everybody, with that said, you're going to be working on these problems here. We're going to be working on these problems here on the next few pages, but just keep in mind, this will help you with some of them. You still need your word wall. You still need your packet to complete this assignment. So get to work, because as soon as it's done, it needs to get checked and you need to turn it in before you leave. Have a wonderful day, everybody.